So today we are looking at the derivative of transcendental function. So transcendental functions include number one, exponential function. That's the first example of transcendental function. Then number two, we have logarithmic function. And number three, we have trigonometric function. Trigonometric function. So these are the examples of transcendental functions. So we want to look at the derivative of each of them. So number one, I'm going to look at exponential function, the derivative of exponential function. So exponential function y equals to e raised to the power of f of x. E to the power of f of x. Now, how do you find the derivative of this? The first derivative of y equals to e of f of x. So in this case, you can now say dy dx, which is the first derivative of y with respect to f of x, will give me f prime x, then multiplied by e of f of x. How do I mean by that? It means the function you see here, you find the first derivative of that, then multiply by the function itself. It is the product of the first derivative of the power of e, then multiply by the function itself. So how do I mean by that? For example, if I have differentiate with respect to x, y equals to e of 4x plus 1. All I need to do is to what? Is to identify my f of x. So in solving this particular problem, solution, my f of x, first of all, is what? 4x plus 1. So it therefore means that if I find the first derivative of f of x, which is 4x plus 1, which is f prime x, it means I'm differentiating this function with respect to x first. So when I differentiate 4x plus 1, if I differentiate 4x, that will give me 4. If I differentiate 1, that will be what? 0, because 1 is a constant. So it therefore means that dy dx is equals to f prime x multiplied by e raised to the power of f of x, and that automatically leads to what? So what's my f prime x here? It is 4. That will be 4 multiplied by e raised to the power of 4x plus 1, and that is my final answer. Please jot it down.